morning.
Good morning.
Good morning, sir.
Good morning to everyone. The recording of the meeting is on now. So let's continue with our session. So beta, last session we had done plane and parallel sailing and Mercator sailing. So first of all, have you practiced those questions, beta? Any doubt or queries coming to your mind related to these two?
Sir, good morning.
Good morning, ma'am.
सर इन प्लेन सेलिंग आप दो क्वेश्चन के आंसर सर गलत आ रहे हैं.
Okay. I saw that message on the group, beta. Did you check it with anybody else, the answer?
Yes sir, I checked with CAF, but sir जो बुक के पीछे आंसर है वो डिफरेंट है.
बेटा, that's all right. That's all right. Book के आंसर्स में गलती हो सकती है. There are some mistakes in the book.
Okay sir.
Okay. So if your answers are matching, not to worry. This is a pretty simple calculation. So I don't think you will be going wrong.
Okay.
Okay. Have you done those questions which Kirat has put on the group? Okay. So silence. Nobody else has done those questions, eh?
Done, sir, done.
Okay. So beta, were the answers matching with the book?
No sir.
Okay, then it's all right, beta. Then the answers given in the book are
Let me check, sir.
not right. Okay, all right. Okay. So any other doubt or query you have in your mind, beta?
सर ये मर्केटर सेलिंग के क्वेश्चंस में एक दो क्वेश्चंस में जो कोर्स था उसमें 1 मिनट का डिफरेंस था और डिस्टेंस में 1 माइल या 2 माइल का डिफरेंस था, तो वो एक्सेप्टेबल है या फिर?
Acceptable, beta. I will tell you the reason for this slight difference. जो आंसर्स एक्चुअली इन्होंने बुक में निकाले हुए हैं, they have been calculated using tables. These questions can also be done using Travers tables. So book के जो आंसर्स हैं, they are found using those tables. So you are calculating these answers using scientific calculators. So that's the reason for this small difference. This is perfectly acceptable.
Okay sir, thank you.
Okay. Okay. So then we proceed further, beta. We proceed to our next topic then, since you all are clear about plane and parallel sailing and Mercator sailing. We should be now proceeding ahead. What we will be using time and again is plane and parallel sailing. The next topic for today, which we have, is the day's work topic. So we will be solving questions related to this day's work. Beta, in the last session, did I give you an introduction about day's work?
Yes sir.
Okay, I showed you a video also, beta.
No sir.
Okay, all right. Okay. So in this day's work method, we use the same plane and parallel sailing जो हमने अभी किए हैं क्वेश्चन जिनके प्रैक्टिस किए हैं, सेम formulas. So the first formula, do you remember the formulas, beta? Anyone? What was the formula for DLAT?
Departure.
Departure by delay.
Okay.
Departure by delay is equal to cost of entry.
Okay, all right. What is the formula for DLAT?
Distance into course.
Distance into course?
Distance into cos course, yes, sir.
Very good.
Distance is
Very good.
cos course.
DLAT is equal to distance cos course. What is the formula for departure, beta?
Distance into sine course.
Very good. The formula is distance into sine course. And what is the formula of tangent course?
D long by DMP.
Departure into DLAT.
Right, beta. You both are right. For plain sailing, it is departure upon DLAT. And if the distance is more and you decide to do Mercator sailing, then it will be D long upon DMP. Now, in days work problems, usually the distance is much lesser than 600 miles. Days work is basically the progress of the ship on its path in 1 day, in 24 hours, in 1 day, from noon to noon. So the distance usually covered is less than 600 miles. So we do not need to use Mercator sailing here. We can use it if we want. There is no restriction about it. But we prefer to use the simpler form. We prefer to use the plain sailing, because in plain sailing, you don't require any table. No meridional part tables are required. Using a calculator, with the help of a calculator alone, you are able to calculate courses and distances. So plain sailing is what we use in this day's work technique, in this day's work method. So we will see, first of all, what is this day's work? It is basically the progress of the ship on its path in 1 complete day for 24 hours. Then we will see how does the question of day's work look like, what all things we are required to calculate, what is asked us in the question to be calculated, and then we will see different concepts or different tricks which can be included in the question. ये सारी चीजें हम one by one पहले देखेंगे, and once we are familiar with all these, then we will actually see a day's work question and we will solve it. Okay, so after that I'll give you a practice question to do. Now this day's work is again given in your practical navigation book. तो कैप्टन सुब्रमण्यम नटशेल सीरीज प्रैक्टिकल नेविगेशन की जो बुक है हमारी, इसमें हमारा एक चैप्टर जो है वो डेज वर्क टॉपिक पे इंक्लूडेड है. सो दैट्स द चैप्टर फ्रॉम वेयर वी विल बी प्रैक्टिसिंग आफ्टर अंडरस्टैंडिंग दिस प्रॉब्लम. सो दैट्स द प्लान फॉर टुडे. So let's go into the presentation and see what is day's work, what does the question look like, what is the concept behind it, and what are the different tricks which are put into the question to make it complicated. Okay, let me first show you a small video which explains the concept of this day's work.
Day's work. Well, a day's work means compilation of data.
Beta, are you able to hear the audio with the video running?
Yes, sir.
Okay. Yes, sir. Yes.
Okay.
Day's work. Well, a day's work means compilation of data. And this compilation of data is required to review the ship's performance. Now, you may wonder what kind of performance we are talking about. Well, the performance means navigational performance at sea. So this is measured from noon to noon. Now the question is why? Well, From ancient time, the latitude of the ship was obtained by sextant using the observation of sun at meridian passage or noon. The meridian passage means noon. Well, this means that the sun attains maximum altitude at noon, like this, and there is a name called latitude by meridian altitude. So from ancient time, latitude of the ship could be measured by simply observing the sun in the afternoon.
Okay, beta, you will be doing these methods in celestial navigation. Have you already started it or not yet, beta?
Not yet, sir.
Okay, so it will come in CellNav. One is this latitude by meridian altitude. Then you will have other methods also, like longitude by chronometer, intercept, X meridian, Polaris. So all these methods will be there with which you can calculate the sites.
Later on, when chronometer was invented and the radio signals were easily available, so we could measure the time, and it became possible to find a longitude once the correct time was known. So both latitude and longitude were combined to obtain noon position. So the noon became the starting and end points of day's work. Hence, this noon report came into existence. Now let me discuss the contents of noon report. One is position of the ship at noon, course and distance and speed made good. Well, I'm going to explain what is the speed made good from previous noon to the present noon. Then set and rate of current, clocks advanced or retarded in case time needs to be adjusted, distance to go, DTG, ETA in export, average RPM within 24 hours, from one noon to another noon, consumption, and remark about weather, wind or wave, or any condition which has affected the speed of ship. So this is another sample of noon report. There can be a little bit variation, but general terms remain same. Now let me define a few terms which are very useful. One is DR position. DR means dead reckoning. And this is the position obtained by true course steered and speed through water. Now suppose this is the current position.
Okay, beta. Now, beta, to understand these terms, dead reckoning position, then there will be another term which is known as estimated position. And then there will be a third term which is known as a fix. So we will understand what these terms are. But please keep in mind that all these terms are relevant when we do not have access to satellite position fixing systems. That means GPS, we are considering that it is not there with us. GPS is not available to us. So what is available to us is only terrestrial bearings, terrestrial observations. It could be the bearing of a lighthouse. It could be the sextant angle of a lighthouse, radar range of a light, something like that. And what is available to us are celestial position lines by different methods. So we do not have GPS with us. So when GPS was not there, what we used to do was when the vessel proceeded, every hour we used to calculate the DR position of the ship. Now, how did we do that? Whatever is your current position, to that position you apply the course steered. You apply the course steered vector. The direction will be governed by what course you are steering, and the length of the vector would be your engine distance, the distance you have covered in 1 hour by your engines. So when you obtain the next hour position, it is called a dead reckoning position or a DR position. It is basically a guess which you have made that the vessel should be somewhere close to this particular position. So the same thing will be explained here in the video also now.
That is the fixed known position. And from this known position, we apply course and speed. So we obtain DR position. It is interesting to know that the course is true course and the speed is speed through water, which means the log reading.
Beta, what is the log? Anyone, can you tell me, beta, what is log?
सर डॉपलर लॉग जो मतलब मींस जो स्पीड इक्विपमेंट स्पीड देते हैं ना सर, उसको डॉपलर लॉग बोलते हैं सर.
Right. Very good, beta. Yes, it gives us two things actually. Log is also known as SDME, speed and distance measuring equipment. So basically ये जो log है ये हमें दो चीजें प्रोवाइड करता है. One, it gives us the speed of the ship. And speed कौन सी देता है ये हमें? It is speed through water. Okay, or you can say engine speed. Both terms are interchangeable. And it also gives us the distance covered by the ship. So we call it log distance. Now बेटा पुराने टाइम में जो logs हमारे पास होते थे, it was known as a patent log. So it was like a propeller and we used to leave it into the water close to the stern of the ship. इसको एक रस्सी से बांध के हम लोग पानी में डाल देते थे. ये प्रोपेलर जब पानी में जाता था तो ये घूमता था एंड जो हमारी रस्सी थी उसमें टर्न्स आते थे एंड द rope used to turn, and with that turning we used to find out how much distance we have covered and what is the speed of the ship. That was the log which we used in old days. Nowadays the log which we are using is the Doppler log. Why we call it a Doppler log? Because it is based on a effect which is called as Doppler effect. So you will study this in bridge equipment. So this Doppler log is used to find out the speed of the ship through water and the distance covered by the ship. And this is what is used when we find out the DR position for the next hour.
However, there could be a wind and current. And because of the wind and current, you can estimate that the position is not at DR, but here at some point, which is called EP or estimated position.
Okay. Yeah. Now we can also understand what is this estimated position. Now, wherever the ship is, it is possible that in that area, there may be some current in the water. Current means that the water is flowing in a particular direction. Okay, you will discuss or read about ocean currents in meteorology. Have you started it or not yet, beta? Meteorology, ocean currents?
No, sir.
No, not yet, sir.
Okay, it will come. So you will read about them in meteorology. So ocean currents are like streams of water, rivers of water in the oceans. So it is possible that in whichever area the ship is, there may be some current in that area. Now, if there is some current in the area, it will take us from the DR position to another position, which we call as estimated position. So estimated position is basically taking into consideration the effect of the current. So this is what is called as a estimated position. अब बेटा DR पोजीशन जो है ये भी गैस वर्क है. ओके, हमने अपना कोर्स स्टीयर्ड तो लगाया है और लॉग स्पीड भी लगा दी है, लॉग डिस्टेंस लगा दिया है और हमने एस्टिमेट करके एक करंट का वेक्टर भी लगा दिया है और अब हम एस्टिमेट कर रहे हैं दैट आवर शिप शुड बी एट EP. बट इट इज पॉसिबल कि जो ये करंट हमने एस्टिमेट किया है, नाउ हाउ कैन वी एस्टिमेट द करंट इन एन एरिया बेटा? कैन एनीवन टेल मी बेटा, एनीवन, हाउ कैन वी एस्टिमेट द
Routing
करंट?
chart.
Very
The
good.
routing chart.
Very good beta. Is there any other way with which current can be estimated other than routing chart? That is the primary source. कोई ऐसी पब्लिकेशन है बेटा ब्रिज में जिसमें इसकी इंफॉर्मेशन होती है? Okay, so the first source of information is the routing chart. Routing chart of a area will tell you what is the set and rate of the current in a particular place. What is the direction and what is the speed with which the current is flowing in a particular place. The second source of information could be the sailing directions of the pilots. So if you go through the sailing directions in whichever area you are, it will give you a good idea of what is the current in that area in that particular month of the year. So we estimate the current from routing charts or sailing directions. Now this estimate could be wrong also beta, because after all it is a estimate. The speed and the direction of the current is governed by meteorological conditions. So there could be a change in that. So that is why it is not necessary that our estimated position will be correct. It is the best estimate which we can make, but our actual position could be at some other place also. Okay, so that actual position is obtained by getting position lines. Okay, so let's see how do we obtain and what is it called.
This position is obtained by allowance for wind and current, or simply estimated wind and current. However, if we obtain actual position that the ship is not at EP, but the ship is at this position.
Now beta, if we obtain a position, actual position of the ship, how can we obtain it? By observation. Either by terrestrial observation, that is the bearing of a lighthouse, the range of a lighthouse, or different methods. We will do these different methods in chart work. So either we can obtain it from that, or you can obtain it from celestial observations. So this position which is obtained by observation is known as fix. And it can be at a different place than the estimated position, because estimated position is a estimate. Fix is the actual position of the ship. So once we know the fix, we can now check what is the actual direction and speed of the current in that area. And once we have the fix, we can also find our course made good and speed made good.
This is called fix. So we can define fix as actual position obtained by one or more means. So that means from DR position to fixed position, that is the effect of current. So we call it set and drift. And from this fix to the next fix, this is called course and distance made good.
Now beta, this triangle which you are seeing on the screen, this is a very important triangle for chart work. So in chart work questions, I would say 90% of the questions, this triangle is used. So you can see in this triangle, we have our starting position. We first apply our course steered and the engine distance covered. So that is the red color side of the triangle. It is also known as course steered vector. Okay, a vector is something which has direction as well as magnitude. So this red color side of the triangle, the direction is the course steered and the magnitude is the engine distance. Then you see the green color arrow. The green color arrow shows us the effect of the current. This is also known as set and drift of the current. The set is the direction in which the current is going or it is taking us. Drift is the distance which the current has pushed the ship in a given time. So that is the green color vector, set and drift of the current. The purple color vector which you see, that is from the initial position to the final fix, is basically the resultant of red and green. So if you get the resultant of red and green, it will give you the purple or pink color vector. And this pink color or purple color vector is known as course made good vector. So if you measure its direction, it will give you the course made good of the ship. And if you measure its length, it will give you the distance made good by the ship in this particular time for which the triangle is made. So this is a very important triangle from chart work point of view. Now in day's work beta, we basically find out what is this course and distance made good. So we are required to find out from one day noon to the next day noon, what is the course made good of the ship and what is the distance made good by the ship. So this is what is required. So beta, any doubts you are having till now?
No.
Very good.
सर जो इनिशियल पोजीशन है और एस्टिमेटेड पोजीशन है उसका कोर्स और डिस्टेंस को क्या बोलते हैं सर?
ओके बेटा उसे वैसे तो कुछ नहीं बोला जाता है, वी डोंट कॉल इट एनीथिंग. हम लोग एस्टिमेटेड पोजीशन को सिर्फ यूज करते हैं. किस चीज के लिए यूज करते हैं? जब हम चार्ट वर्क करना शुरू करेंगे तो मैं आपको वहां पे एक टेक्निक करवाऊंगा जिसका नाम है काउंटर एक्टिंग द करंट. ओके, सो जब हम इसे काउंटर एक्ट करते हैं या अलाउइंग फॉर द करंट, ये दो टेक्निक मैं आपको कराऊंगा. सो व्हेन वी डू दैट, उसमें आपको पता चलेगा कि हम ये एस्टिमेटेड पोजीशन को कैसे यूज करते हैं. Before you proceed on a course, you use the estimated position to find out where the vessel will land up. Okay, so ये चार्ट वर्क में हमें क्लियर हो जाएगा. So अभी के लिए it is not required. Okay, now बेटा अभी जो ट्रायंगल हम देख रहे हैं, this triangle, it consists of only one course and speed. Now, when the ship goes from one day noon to another day noon, it is possible that the vessel may be steering different courses. For some time, let us say from noon to 1600 hours, it may be steering one particular course. Then there may be a course change. A waypoint may come and you may change your course. So for some time, you may be steering another course. Later on, after 3-4 hours, the course may again change. So when you check the progress of the ship from noon to noon, it is possible that the vessel may have moved on different courses and distances. तो हमें बेटा ये सारे के सारे courses और distances का resultant निकालना होता है, which is known as the course made good and the distance made good. So how do we find that resultant? That we will see in day's work questions. So this is basically what we call as day's work. So clear up to here, beta? Any doubts up to here? Any more doubt queries coming in your mind?
Sir, then the resultant course which we have followed from the one noon to the another noon, that may cross from the land, sir. That may be possible, right?
That's possible, beta. That's very much possible. So इस केस में वो लैंड के ऊपर से भी क्रॉस कर सकता है, बट वी नो कि कोर्स मेड गुड और डिस्टेंस मेड गुड जब हम निकालते हैं तो इसका मतलब ये नहीं है कि शिप उसी ट्रैक के ऊपर चला है. सो बट इट इज परफेक्टली पॉसिबल.
Okay, sir.
Okay, like say you are on east coast of India and you round off Sri Lanka and come to west coast of India. Next day you are on west coast. So जब आप अपना course made good और distance made good vector बनाओगे, it may pass over India. Okay, but that does not tell us that the ship has moved on this track. So what you are saying is right. That is possible. Okay, beta. So let's go back to the presentation. We understood the basic concepts now. So we will see what day's work is in detail. Let's switch on the mic now.
Okay, beta. Other people can please mute their mics. Okay. So as we just now discussed, day's work is basically a summary of the ship's passage from 1200 hours on one day to 1200 hours on the next day. We have to make this summary. Now, as we discussed, various courses and distances or speeds on different legs of the passage are given to us in the question, and they want us to find out the resultant course made good, distance made good, and what is the position arrived at the next day noon. Okay, so it is something like this. Let me pick up the pen. Let's say on a particular day, we were at this particular position. Now, let's say we steered a particular course. This was the first course which we steered. We were here at 1200 hours. We steered this particular course for, let us say, 8 hours. So at 2000, we reached here. Then after 2000, we altered our course. So the next course was this one. And after another 8 hours, so that means 0400, the ship was here. Then at 0400 again, the course was altered. And the third leg of the course was this one. And next thing known, you are at this particular position. So what they want us to find now is, they will give us the position at the starting time. This position will be given to us. The latitude is given. The longitude is also given to us. So what they want us to find out now, what is the position arrived at next day noon? This is what we need to find. So can you tell me, beta, how can we find this using plane and parallel sailing? The courses and distances are also given.
ऐसा 3 डिफरेंट उससे फिर कैलकुलेट करेंगे.
By course and distance, we will get the lat and long of another position.
सर lat and long, d lat and d long का कैलकुलेट कर लेंगे सर.
Very good, beta. So the first method which comes to our mind is कि हमारे पास ये 1200 आवर्स की पोजीशन है. इस पे अगर हम ये कोर्स और डिस्टेंस अप्लाई कर दें, हमें इसे अप्लाई करना आता है यूजिंग प्लेन एंड पैरेलल सेलिंग, तो हमें 2000 आवर्स की पोजीशन मिल जाएगी. एंड जो हमारा सेकेंड कोर्स और डिस्टेंस है, अगर हम इसे भी अप्लाई कर दें तो 0400 की पोजीशन आ जाएगी. एंड इफ वी अप्लाई द थर्ड कोर्स एंड डिस्टेंस, we will get the 1200 hours position. So this is the method which comes to our mind. Okay. So is there a shorter method also, beta? Anyone? Okay, I will tell you now. अब बेटा this method is perfectly correct. हम लोग डेज वर्क के साथ इस मेथड को यूज कर सकते हैं, बट इसमें दो हमारे पास इश्यूज आते हैं. एक इशू तो ये आता है दैट दिस विल बी ए वेरी लेंथी मेथड. हमें पहले 20 आवर्स की पोजीशन निकालनी होगी, फिर 0400 की निकालनी होगी, और फिर नेक्स्ट डे नून पे हम पहुंचेंगे. और अगर किसी डे में शिप ने ज्यादा कोर्सेज, ज्यादा लेग्स को स्टीयर किया है, लेट्स से यू आर कोस्टिंग एंड यू हैव 8 legs, 8 courses and 8 distances, so this method will become very cumbersome. ये बहुत लेंदी हो जाएगा. हमारे पास एक और शॉर्टकट मेथड है जिससे हम इजीली कम टाइम में नेक्स्ट डे नून की पोजीशन को डायरेक्टली निकाल सकते हैं. दूसरी चीज बेटा ये है, इस मेथड में वी आर फाइंडिंग द पोजीशन ऑफ द शिप एट 2000 आवर्स, वी आर फाइंडिंग द पोजीशन एट 0400 आवर्स. मतलब जितने भी वे पॉइंट्स आ रहे हैं हमारे, हर एक वे पॉइंट की पोजीशन हम ढूंढ रहे हैं. अब इस मेथड में उन्होंने हमसे पूछा नहीं है, दे डोंट वांट अस टू फाइंड द पोजीशन ऑफ द वे पॉइंट. व्हाट दे वांट अस टू फाइंड इज द पोजीशन एट नेक्स्ट डे नून. सो व्हाट वी डू हियर इज, आई विल टेल यू, फॉर एवरी कोर्स एंड डिस्टेंस, कोर्स नंबर 1, डिस्टेंस 1, इसके लिए बेटा हम लोग डीलैट और डिपार्चर निकाल लेते हैं. तो व्हाट वी फाइंड आउट इज द डीलैट एंड द डिपार्चर. इसी तरह से सेकंड लेग के लिए भी हम डीलैट और डिपार्चर निकाल लेते हैं. थर्ड लेग के लिए भी डीलैट और डिपार्चर निकाल लेते हैं. तो जितनी भी लेग्स हमारे नून टू नून के पैसेज में हों, for every leg we find out the departure as well as the delat. Now the good thing is that this departure and delat can be combined together. So जो भी हमारा delat आया है, इसको हम combine कर सकते हैं. फर्स्ट लेग का delat, सेकेंड लेग का delat, थर्ड लेग का delat, it can be combined. Combine कैसे करते हैं? Now बेटा delat could be either north or south. ये दो ही डायरेक्शन में हो सकता है. डीलैट कुड बी नॉर्थ, डीलैट कुड बी साउथ. तो जितना भी नॉर्थ डीलैट होगा उसे भी हम ऐड कर लेते हैं, जितना भी साउथ डीलैट होगा उसे भी हम ऐड कर लेते हैं. एंड इन द एंड दोनों में से जो भी बिगर वैल्यू है उसमें से स्मॉलर वैल्यू को सब्ट्रैक्ट कर दिया जाता है एंड वी रिटेन द नेम ऑफ द बिगर वन. दैट इज हाउ वी कंबाइन द डीलैट और ऑन ऑल द लेग्स ऑफ द कोर्स. We can combine the departure also in the same way. Only difference is departure east या west होता है. So we add up all the easterly departure, we add up the westerly departure, and in the end, whichever is the bigger value, उसमें से छोटी वैल्यू को subtract करते हैं and we retain the name of the bigger one. So हमारे पास क्या आता है? हमारे पास आता है resultant delat and resultant departure. मीन्स पूरे के पूरे लेग्स को डीलैट और डिपार्चर कंबाइन करने के बाद हमारे पास ये रिजल्टेंट डीलैट और रिजल्टेंट डिपार्चर आ गया. नाउ दिस डीलैट एंड डिपार्चर इफ अप्लाइड टू द इनिशियल पोजीशन will straight away give you your final position. So this is what we do in a day's work question. अब मैं आपको ये एक एग्जाम्पल हम लोग पिकअप करेंगे एंड वी विल सी प्रैक्टिकली हाउ दिस इज एक्चुअली डन. ये मैंने ब्रीफली आपको समझाया कि डेज वर्क के प्रोसेस को हम लोग कैसे करते हैं. ओके, लेट्स प्रोसीड अहेड नाउ. So the first step is to put all the data in the tabular form. So tabular form में सारे के सारे डाटा को डालते हैं. The data is given to us in text format. Okay, it is given to us in text format. Question में हमें words दिए रहते हैं, language दी रहती है, text दिया रहता है. हम इस text से एक table बनाते हैं. So I will show you what type of table we make. So when we make this table, सबसे पहली चीज जो हमारे पास आती है, let me erase the ink on the slide. So जब हम ये टेबल बनाते हैं तो पहला चीज, फर्स्ट स्टेप जो हमें करना होता है, यूजली इन द क्वेश्चन दे गिव अस कंपास कोर्सेज. ओके, so we have to convert all these compass courses to true courses. Okay, so this could be a compass course, a gyro compass course, or a magnetic compass course. We have to convert it to true course, and once we have the true course, we have to convert it to quadrantal notation. Quadrantal notation में क्यों convert करना है? Because in day's work the question is always solved using the course in the quadrantal notation. हमने देखा है कि जब भी हम plane and parallel sailing questions करते हैं, so we always use the course in the quadrantal notation. So we do not use it in three-figure notation. So this is the first step. Convert all compass courses to true courses and then to quadrantal notation. तो बेटा, does anyone remember कि हमने प्रीसी में किया था how to convert compass to true and true to compass? किसी को याद है?
So CDMVT.
Applied deviation and variation.
Very good बेटा. CDMVT. Cadbury's Dairy Milk, very tasty. So let's see the conversion of compass to true. How do we do it? When they give you a compass course, they will give you a deviation as well as a variation. So we apply this deviation and variation to convert the compass courses to true courses. How do we do that? We are given a compass course. We apply the deviation first. Okay. What do we mean by apply? Apply means that it could be added or it could be subtracted. So when the deviation is west, compass will be best. Compass best means you have to subtract the deviation to go to the magnetic course. And when the deviation is east, that means compass is least. Compass least means you have to add the deviation to go to the magnetic course. तो बेटा ये याद आ गया, deviation west, compass west, deviation east, compass least.
Yes, sir.
Very good. So we first apply the deviation, and when we apply the deviation, we get the magnetic course. And once we have the magnetic course, we apply the variation now. Variation is also applied in the same way. Variation west, magnetic best. Variation east, magnetic least. And as you apply the variation, you find out your true course. Now you see, you can easily remember it from these initial letters, C, D, M, V, T. So you want to go compass to true, C, D, M, V, T will help you. How to remember it? Cadbury's Dairy Milk, very tasty. Okay. You can have other idioms also. So there are a lot of idioms which can be used for this. Okay. So some of them are secret idioms, so you can keep it to your mind. But this one is a pretty good idiom to remember. The main idea is not to forget the way or the order in which these corrections are applied. So this is clear, beta? This is clear to everyone?
Yes.
Okay. Now, beta, you can note this down in your notebook, or if you want, you can take a screenshot and save it with you. आप बेटा ऐसे करना कि चार्टवर्क सब्जेक्ट के लिए just make a folder on your device. Okay. तो आपके लैपटॉप या डेस्कटॉप पे एक फोल्डर आप बना लेना, एंड उस पे इनको आप जो भी चीजें इंपॉर्टेंट होंगी, आई विल टेल यू टू टेक ए स्क्रीनशॉट एंड सेव इट, सो यू कैन कीप ऑन सेविंग इट इन योर डिवाइस. Later on, when you are revising, it will help you. Okay, so you can give it a number. You can start giving it a number 1, 2, 3, 4, 5, 6. So when you revise, you know you start from number 1, you keep on going ahead, and all these items will be there. It will help you to revise the subject very quickly. Okay, so let's proceed ahead, beta. We now know how to convert compass to true. When we go in chart work, we will be converting from true to compass also. So that time I will tell you how to go back from true to compass. But for now, only this is required. Okay, the next concept which we have is the concept of leeway. Okay, so we should know what is this leeway and how this leeway is applied. This is also a very important concept, beta, not only used in day's work, but is used in chart work also. So when we do chart plotting questions, you will see in many of the questions, they will provide you with this leeway and you will need to apply this leeway on the chart or on the answer sheet. Okay. Now, beta, one request. If at any time you feel that it is becoming too much for you, just give me a hint and we can stop there. Huh? तो कभी भी आपको ऐसा लगे कि HLA high level alarm आने वाला है, ALEJ is reducing, just tell me, I will stop it here immediately. Yeah? Okay, so yes. For now it is okay. Can we continue?
Yes, sir.
Okay, perfect. So what is this concept of leeway? Leeway basically means how much a vessel is pushed downwind. Downwind means the wind is pushing you in a particular direction. Whichever direction the wind pushes you, that is known as the downwind side or the leeward side. So how much a vessel is pushed downwind of its intended course when navigating in the presence of wind. That is what leeway is. Let me show this to you by way of a diagram. Now you can see this ship. This ship is actually steering course 090. The ship is steering a easterly course and there is a wind in the area. This is the wind. Now, beta, if the wind is coming like this, what direction do you call it? Is it northerly wind or southerly wind? It is coming from north and it is going to south.
Northerly, sir. Northerly.
Northerly, sir. Coming from.
Very good. So people are smart. So wind direction is always the direction from where it comes. So we will call this wind as northerly wind. Now, beta, if we have a current in the area, let us say we have a current. Current is represented by 3 arrows. So if we have a current in this area and the current is also coming in the same direction, coming from north and going to south. Now, can you tell me what we will call this current?
Suddenly, sir.
Suddenly.
Very good, beta. Very good. So you people are clear about the concept of wind and current. Wind direction is always given from the side from where it comes. And current direction is always given for the side in which it is going or it is taking you. So this wind is northerly wind and this current is southerly current. Very good. Let's erase the ink. So our ship is steering a course of 090. Now we have northerly wind in this area. So northerly wind will be pushing on my ship from the port beam like this. It will be pushing on my ship. So because of this wind pushing, it is something like as if a tug is pushing me and the ship will not be able to move on 090 track. The track which the ship will be moving on is the solid color track, solid line track which you see with the arrow. This is the track on which the ship will be moving. And this is known as leeway track. Okay, so this is known as leeway track. And this angle here, the angle which we have, this is the angle between the course steered and the leeway track. This angle is known as leeway angle. So this is what we call as leeway angle. Now, important thing to understand here, beta, is very important. vessel will always keep on steering 090. Let us say in a particular case, this leeway angle is 10 degrees. Okay, vessel was steering 090. Can you tell me, beta, what will be the direction of the leeway track?
100.
100.
Very good. The leeway track would be 100. Now, important thing to remember is that the vessel's heading will always remain 090. Vessel की heading change नहीं होने वाली है 100 पे. 100 ट्रैक पे वेसल बॉडीली मूव करेगा, लेकिन वेसल की जो हेडिंग है वो 090 ही रहेगी. द हेडिंग इज नॉट गोइंग टू चेंज टू 100. इन अदर वर्ड्स व्हाट आई मीन इज कि हमारा शिप जब यहाँ पे पहुंचेगा तो शिप बेटा ऐसे होगा, हेडिंग तो होगी 090, बट जिस ट्रैक पे शिप चल रहा होगा वो ट्रैक होगा 100. So course steered does not change because of wind. Course steered तो फिक्स है बेटा, वो तो ऑटो पायलट में हमने 090 डाल दिया, तो ऑटो पायलट इंश्योर करेगा that our heading remains 090 only. What will change is our track on the water. So vessel will be moving on the solid line, but vessel will be steering the dotted line. So I hope this is clear, beta, clear to everyone.
Yes, sir.
Very good. So beta, let's take a break now. Our first session is coming to an end. So we will have a break, and after the break, I will show you a small video on leeway, and then we will proceed further to the next concepts which are there in day's work. So let's meet back after the break.
Thank you, sir.
Thank you, beta.
Thank you, sir.
Thank you, beta.